Okay, so let's start out on switch 1, and let's just take a look and do a show CDP neighbor and see what we have. And we see that we have 3 phones, and those phones are on fast 010, fast 011, and fast Ethernet 012. And if we do a show CDP neighbor details for fast, let's say 010, we note that we see its skinny version. We see what type of a phone it is, a 7961. And we see that it's drawing 6.3 watts of power, or at least it says it is. But if we do a show power in line, we actually see that fast 010 has no power. It's not taking any power at all. So this is what I was talking about in terms of the tunneling that you can expect to see in the real lab. Okay, so it looks like the phone is connected to fast 010 to this particular switch, this is a 3560. Okay, it looks like it's connected to this 3560 switch. It looks like it's drawing power from it via CDP, but really that's all CDP is being relayed from the real switch, which is actually providing the power, and everything is tunneled through layer 2. So another good thing to do, I'll clear off my screen, would be to do show run pipe to include CDP. And we see currently the only thing is CDP timer 6 is enabled globally. Globally, we see that we can do CDP advertise version 2. So if I go ahead and key that in and do show run pipe to include CDP, I note that nothing shows up. That's because it's the default. So if I took that off and then did the show run, now I would see no advertise CDP version 2. So again, just a good idea to do a show run pipe to include CDP and see what is configured related to CDP on your switch port. I'm going to do show run interface fast Ethernet 010. And I actually did 010, but 0/010, but that still works. And currently I see that I'm using access VLAN 11 and switch port mode access. Now VLAN 11 do show VLAN brief. VLAN 11 is my voice VLAN. So another way that we could do things is we talked about we could have a trunk mode where this is switch port mode trunk, and I've got switch port voice VLAN and access VLAN being something, switch port mode voice VLAN and a native VLAN ID being something separate from each other, a voice and a data VLAN. I could also do access mode where this is set to switch port mode access, and the access VLAN is, let's say, VLAN 12 as we see down here, which is the data VLAN, and the voice VLAN is VLAN 11. So switch port voice VLAN 11. And there's another way, which is just simply using access mode and having everything in the same VLAN. So access VLAN 11, as long as my phone is in the voice VLAN, its PC port is not in a separate VLAN, which is not the best for security, but it does work. Okay, both ports separation of VLAN ID for traffic classification, for anything such as security. And again, it's not the best idea for an enterprise environment, but it is an acceptable configuration. It will work. Okay. And I'm actually not going to change it because of my layer 2 tunneling. I'm going to leave it in access VLAN. Okay. In the real lab, they may have it set up differently, and they may want you to use the voice VLAN. You certainly know how to do that. It shouldn't be too big of an issue. Okay, so I've got all my phones in their proper, whoops, I meant to do the show VLAN brief again. I've got all their phones, fast Ethernet 10, 11 in their proper ones. My fast Ethernet 012, which is a phone, is actually my PSTN phone. And so that's connected there, as well as port 4, which goes out to my PSTN device. So everything's in their proper VLAN from this perspective. And actually, let's go ahead and bring up a topology as well. Okay, so I'm going to zoom in just a little bit and then we'll scroll around with this. But here's the topology that we're going to use. This is very similar to the topology you'll see in the real lab. The real CCI voice lab is actually one of the few, if maybe the only CCI labs that really publishes the topology and they publish it as a sample topology, but have for the most part stuck with it throughout the testing. So it's one of the nice things, I suppose, about it. It being a very difficult test in and of itself already. So we see that we have all of our we've got all of our servers up here in the corporate headquarters site, and they're hanging off of VLAN 10 using the 177.1.10.0/24, so 255.255.255.0 subnet mask. We've got a voice and data VLAN being 11 and 12, where our phones sit. We do have our PSTN phone connected to switch 1. This is the same way we have it in our racks. This is not what you would probably see in the real lab. You would actually see that phone really connected off of the PSTN router or a separate PSTN switch. So you really wouldn't see a switch per se with that on there. But that's the way that we're doing it, so that you have control over it and you can see it and access it and change anything that might need to be changed. We're doing a trunk between our switch, our 3560 switch, which is really no different than a 3750 for all intents purposes. Really everything is the same except for the stacking capability of the 3750 and therefore the naming of the 3750. In the 3560 we have names like FA 0/5, and if this were a 3750 it would be FA 1/0/5, indicating the stacking switch number that we're working with. Okay, we've got, if I scroll down a little bit, and I guess let me go back and say for our pub and sub, our pub is .10, our subscriber server is .20, Unity connection is .30, UCCX is .40, presence is .50, our XP utility test machine is .100, where we'll use things like CUPC and that's most of what we'll do on there. Various other things. Oh, RTMT might be one of the things that we'll do on there. And then our Active Directory is actually on a separate subnet. It's drawn up here with the rest of the servers, but the IP address is in red to let you know that it's a separate subnet. This is our DNS and Active Directory server. It's 177.1.100 instead of the third octet being 10. It's .100.110. Okay, so if you might potentially have an Active Directory, LDAP, or DNS server in the real lab, it would be on some sort of backbone, but it's really up to the lab as to whether you might have one on any given day. Okay, so let's scroll down. We see that our corporate headquarters site is attached with a T1 PRI to the PSTN, as is our branch 1 router 2, and our branch 2 router 3 is connected with an E1 PRI for an international. We're connected through a frame relay network, which is what the has. So we've got out to the frame cloud, we've essentially got a T1, and then we've got a single PVC over to branch 1 and a single PVC over to branch 2. So we are using a hub and spoke topology. Oops. Okay, down at branch 1, we've got the same VLAN 11 and 12, but you can see those hang directly off of the router. Okay, so that means that we are using the Ethernet switch module, NM4 ESW here, and we've got one phone hanging off of that Ethernet switch module. Over at branch 2, The real lab would either use at branch 1 or branch 2 or potentially both the 4-port Ethernet switch module, or it might use two 3750s, and then one site will definitely have the 4-port Ethernet switch module. It would most likely be that two sites have the 4-port Ethernet switch module. We, just to save some costs so that we didn't have to pass it on to you, we're still using an older 3550 here. It's simply for layer 2 connectivity. All of your configuration and testing for 4-port Ethernet switch can be done on router 2, and of course all of your testing for the 3750, 3560 can be done back at corporate headquarters. Okay, but for the sake of this rack, we do have a 3550. You don't ever have to configure it if you're renting rack time from us. We won't configure it in this lab or this class just because it's not part of what you would be doing. You won't be using the 3550 for anything. Okay, but we can test out everything else on the other two switches. We've got two phones over at branch 2. So we've got two 7961 phones at branch 2, one at branch 1, and we've got two 7961 phones at corporate headquarters, and then we've got one 7960 phone for the PSTN. Now on this particular topology, just so no one's confused, you do see a number of phones and a indicator, a router that says your router, your place of study. This is just if you happen to be using your study with our racks, your routers, your phones with our racks to extend the network out through network extension mode and IPsec, then EasyVPN, we allow that, but we're not going to be using that at all for this particular class. So you can ignore that anytime I pull up the topology for this class, but that's certainly available if you want to rent rack time from us. Okay, so we've got the corporate headquarters set up. Let's go ahead and bring up our router 1 and ignore this. This is just some scripts that I have set. Every time I telnet in, I turn on term on and debug ISDN Q931, which with testing your dial plan, or actually testing just about anything, unless you haven't yet got a PRI configured yet, it's a good idea to be doing that in your self-study and in the real lab. Okay, so let's just clear this off, and let's go ahead and set up some DHCP pools as we talked about. So the first thing we'll do is we'll look at IP DHCP excluded address command. First of all, if I do show run pipe 2 section DHCP, I don't believe I have anything in here currently. No, I don't. Good. Okay. If we set up our DHCP pools, if I go ahead and set up a pool called headquarter phones, then the problem with this is as soon as I see a request, I'm going to go ahead and start handing out IP addresses. Now, if my first IP address in, let's say, pool 177.1.11.0 would be 177.1.11.1, because that's the iOS routers hand out beginning from .1, the CUCM server being a Linux server. The DHCP daemon hands out beginning at .254. Okay, I would run into a conflict because do show run pipe 2. Actually, I should say do show IP interface brief pipe 2 exclude unassigned. So just those interfaces with an IP address assigned. I see that I have one already, so I would sense the conflict, or I would ping it, and it should avoid it, and everything should work fine. However, maybe you were told to have an exclusion range. So let's say only hand out addresses between .15 and .20, something like that. If you don't configure your exclusion range first, you'll go ahead and begin handing out IP addresses in essentially the exclusion range. Now you can put in the exclusion later, but what you'll have to do after that, if that's what happens, is just power cycle your phone. Okay, just pull the power, put it back in, or you could go into the phone settings, whichever you think is quicker, and do a DHCP release, save, and then
release, set that back to no, save, and you would get a new IP address. Okay, but I'm going to go ahead and do 177.1.1 being my low address that I want to exclude, and my high address being 177.1.11. Now we said, let's say 15 through 20. So I would exclude through .14 so that the first IP would be 15 that was handed out. Now I would also need to, even though I should never hand out anything higher than 20, I would also need to go ahead and say, if I was 15 through 20, my next low address would be 21, and then 177.1.11. Let's say 254. 255 is, of course, the broadcast IP. Okay, so that would be a way that I would ensure that I would only hand out IPs .15 through 20. So after the IP of 14, before 21. Now I could go ahead and say IP DHCP pool and call it corporate headquarter phones and give it a network address. I actually like to put in all the rest of my specifics first before network, because as soon as I enter my network, I'm able to hand out IPs. I've given it an IP range to hand out. I want to make sure that the phone gets other things, such as option 150, or you can do option 66. Option 66 can be used for an IP address or for an ASCII domain name. So, maybe CCM cluster 1 -pub, something like that, .ine.com. A fully qualified domain name. Of course, the phone would also have to have a DNS server, so that would have to be one of the options that I handed out. Option 66 can do an IP address. Option 150 can only do IP addresses. It cannot, you can configure ASCII, but it's not a valid value or argument type per the RFC. So option 150 is when I want to hand out IPs, and I want to hand out more than one IPs. That is, I want to have an array. If I'm handing out option 66, I said you could do an IP, but you can only do one. So it's a fully qualified domain name or a single IP. Okay, so here we'll do 177.1.10.10, which is our publisher. We might also have 177.1.10.20 as a subscriber, as a backup. Okay, it just depends on what our lab exam tells us. I'll go ahead and put it in as a backup, 177.1.10.20. Okay, and notice I just have a space separating the two. I must have my default router. 177.1.11 is the subnet that they're on. .1 is the IP address of this router. And now let's go ahead and add DNS as well. So DNS server 177.1.100.110, as we saw on our topology, is our DNS server. And then I'll go ahead and now do network 177.1.11.0, and I can either key in 255.255.255.0 or just /24. So let's clear off the screen. Do show run pipe to section DHCP. I see my excluded addresses, and I see my phones pool. Now, because this router is the same router as where my phones I should say this router is a part of the broadcast domain. So VLAN 11 from switch 1, which is 177.1.11. Okay, the second octet is what we use in our topology to define site number. 177.1.11. Those phones are here local. If I was debugging, which I will be doing in just a minute for the next pool, then you would see that the request is coming through and I'm handing out IPs. Now I can go ahead and just do or just out and say show IP DHCP binding, and I should see that I have handed out two IPs to my two phones at corporate headquarters, .15 and 16. Okay, I didn't see the request because I wasn't debugging. We will do that for the next one. So over in router 2, which is our branch 1 router, again, let's do a show IP interface brief, pipe to exclude unassigned. I see that I already have a VLAN 11 created.
Well, at least I have an SVI, a switch virtual interface. Let's do a show. Let's do a show inventory to see what hardware we have. And this is where our 4-port Ethernet switch module is. Okay, so if I do a show CDP neighbor, I see that corporate headquarter router is attached. It's a 2811 through serial 001:0 because it's a I've got a channel group up set as channel group 0 and .1. It's a sub interface, and it happens to be the same IP, or sorry, the same interface naming on the other side, the corporate headquarter side. And on fast 01/3, I have my IP phone. That's layer 2 VPN. Looks like it's here. Okay. By the way, I know it's going to be 01 even before I looked over there, simply because if I look up at the show inventory, I've got my 4-port Ethernet switch on slot 0. So there's the first 0. Subslot 1. So slot 0 is the motherboard. Subslot is the slot port that I have on the front of the router, or back, depending on how you want to look at it or call it. So it's not the first slot. The first slot, slot 0. I'm sorry, subslot 0 on slot 0, or the actual slot 0 on the motherboard, is my 2-port VWIC MFT, so 2 MFT T1. So this is the second port, counting canonically, slot 1. So I'm going to be 0/1/, and if I'm counting canonically, 0, 1, 2, 3, it's the last port. That's where I find my phone. Okay, and if we do a show run interfaced, fast 0/1/3, I'll see that I've got this set up for access VLAN 11 and spanning tree port fast. Okay, so let's do show VLAN. Remember, there's show VLANs or VLAN switch. We want VLAN switch. And here I do see that I have VLAN 11. It's not named. I could certainly do that. Say VLAN 11, name voice, VLAN 12, name data, not date, data. There we go. And do show VLAN-switch. Oh, and I actually have to exit out before that VLAN 12 will take effect in its naming. Okay, and now they've got their proper names. So, as I mentioned, show IP and interface brief. I also have an SVI. So let's do a show run interface VLAN 11. And I see that I've got my SVI switch virtual interface with my IP address, and I actually already happen to have a helper address. I'm going to go ahead and change that. I thought I deleted all the config. I think that's the one thing I forgot was the helper address. So I'm going to jump into interface VLAN 11, and I'm going to change my IP helper address to, let's say, you know what? Let's leave it there. That's the loopback of router 1 at corporate headquarters. I'm going to go ahead and leave that there. We'll send router 2 or the branch 2 site phones to the CUCM to get their IP addresses from there. So let's just go ahead and leave that right now, set to the loopback. And what we're going to go ahead and do is let's debug IP DHCP server events here on the corporate headquarter router. So we've already got turn-mon turned on, which is useful if I'm telnetting in, of course. It echoes the syslog, sends it out to my terminal session as well. Just because I have that turned on does not mean that I'll see syslog or console messages. I need to make sure that logging's turned on as well. It is by default, but it's helpful just to do a show logging and make sure that, in fact, monitor logging is set to level debugging. Okay, console logging might be on. You can certainly go in through the console and you should expect to see log messages or syslog messages, but again, remember, inherent troubleshooting, they might have just turned off logging globally for you. Okay, and here my logging to VTY 514. If I do a show user, Show users. There we go. Oh, it did show it. VTY514 is who I am. I can tell because of the little asterisk beside of it. And show logging showed that there was a, if I can find it again in all my scroll back messages. There we go. It showed that it was also logging to VTY514. That's the term mon. If you want to turn off term mon, it's not no term mon, it's term no mon. It's one of the few times when I have a little bit different wording. Term, terminal, and then no monitor. Okay, that turns it off. Show logging shows me that monitor is still logging. However, it's not logging out to any particular VTYs or terminals. Okay, enough about that. So let's go to turn mon back on. And we were seeing some DHCP requests. Let's look and see back at branch 1. Show CDP neighbor. The MAC address ended in Bravo Alpha Alpha Echo. So we should see some requests from that DHCP. Okay, this is Foxtrot 1 Delta Echo, so that's a IP that's actually over at corporate headquarters still. Here we go. Here's our Bravo Alpha Alpha Echo. Let me scroll up so we can stop the... So seeing if there's an internally specified pool class, character address 001 Bravo 5452 Bravo Alpha Alpha Echo, and it says there is no pool for 177.2.11.1. Why did it say 177.2.11.1? Because if I'm back over on router 2, 177.2.11.1 is the IP address, the layer 3 IP, of the person or entity node that took the broadcast for a DHCP and turned it into a unicast. So it's essentially being a relay. It's taking that, it's going to relay that information, and it's saying, hey, I've got an IP, but I need an IP address for this MAC address, even though you can't reach that MAC address locally because we're on different broadcast domains. Can you assign an IP and hand it back to me, and I'll hand it back to that individual? So this switch virtual interface is handing it back to the phone, or would be if there was a pool defined. Okay, so we're going to see some messages here, but let's just go ahead and say config T, and we're not going to do an exclusion range on this one. We know we could. IP DHCP pool, and we'll say branch 1 phones. There's no need to type exotic names for anything. Just make sure they're intuitive. Make sure you remember what they are in the lab. Let's do show run pipe to section DHCP because we can reuse a lot of what's in here. So I'll just copy most of what's in here. Oops. And I'm going to edit, grab my text edit, and I'm going to paste it in here, and I'm going to change the variables. So you would do this in the real lab if you can copy and paste. You may be using secure CRT in the real lab. You may be using PuTTY. So be familiar with both. Secure CRT you copy and paste with control insert to paste. I'm sorry, control insert to copy. Just remember C for control for copy. So control insert to copy and shift insert to paste. Or you can right click if you have right click capabilities. Just depends on how their Microsoft group policy objects have the candidate PC locked down. Okay, the TFTP addresses stay the same. The default router changes, and the DNS server stays the same. Okay, so I believe I'm already in the pool for branch 1 phones, and I can paste all that in there. And now, okay, so all of a sudden we saw this add 177.2.11.1 to 254. We've got the range available. So now all we have to do is wait for that request to come back in. Right now we're seeing requests from the router 3 or branch 2 site. Okay, these are some more corporate headquarter phones. Just doing their
every so often request. We could change the lease time. They're not really asking for a new IP. They're just making sure that one is available. Since they can't really contact the TFTP server to download their config yet, they're just checking to see if DHCP was really being honest and telling them the right TFTP server. So we just need to wait for another request to come in. Here we go. We've got the request from Bravo Alpha Alpha Echo. And here we go. We've got a DHCP ping conflict. Let me scroll up. Of 177.2.11.1. So we're adding a binding to the tree for the next available IP. We've assigned that next IP of 177.2.11.2 to the client. And notice this is a little bit different than the MAC address that we saw earlier. This is the client identifier, which always starts with 01 for Ethernet. So we see a client identifier as opposed to a MAC address. It is the MAC address, but it's got 01 prefixed to it. So that shifts the dotted decimal notation over. We've got 4 characters and then a dot, 4 characters and then a dot, 4 characters, and then the last 2 characters of the MAC address. This portion is the MAC address, and this specifies that it's on Ethernet. The client identifier, rather than the MAC address, is what we would use if we're trying to assign an IP address to a specific client or specific node, whether it's a phone, PC, Mac, really doesn't matter as long as it's on Ethernet. Okay, so if you're trying to isolate a single pool for a single client, make sure just do a create a normal class. Let's just undebug all here. Create a normal DHCP pool and do a show IP DHCP bindings, and see that the client identifier, see how that works, see how it's assigned, and grab it in its existing format, delete your other pool, and put in the client identifier. Okay, so here's what I mean by that. Show run pipe 2 section DHCP. If I was told to hand out just an IP address to that one branch 1 phone but no one else, I could jump into my branch 1 phones pool, and instead of saying network, well, actually I could still say network, but I could give it a host IP instead. Okay, instead of a network, but I could say client identifier, and the client identifier is copy and paste. And now what I've done is, and it says I can't use it with network. I have to use it with host. Okay, so I'd have to change the network command. I'd have to delete that and make that a host, and I'd have to give it a valid host IP, and then I could use the client identifier, and I would lock that pool down to attributes and an IP for one specific client or node. As it sits, I didn't modify it, and we see the branch 1 pool is left untouched. Okay? So over at router 2, if I do a show CDP neighbor details, I should see that this phone has 177.2.11.2. Likewise, at my corporate headquarters switch, show CDP neighbor details. I'm actually going to do fast 010 details because I want to isolate it. Looks like I've got 18 as an IP. And if I look at 11, I've got 16 as an IP. Does router 1 reflect that? Show IP DHCP binding. Yep. .16 and .18. So we probably handed out, I believe we start at 15. We probably handed out 15 and 16, and then a phone is sitting there frantically trying to register with the DHCP instructed TFTP server. Can't do it, so it goes through a recycle and tries to get a new IP and new TFTP, and like I said, a frantic attempt to register. And it'll keep doing that until it either burns up or finally gets registered. Okay, so let's go over and take a look at our router 3. Show CDP neighbor. I don't have any phones connected here because I've got my branch 2 switch. As I mentioned, there's nothing you need to do on this branch 2 switch. If you're using our racks, we always pre-configure them, pre-configure this particular switch.
because as I mentioned, show version pipe to included is a 3550. Okay, so show VLAN brief. We've got our VLAN 11 set up. We've got fast 0, 10, and 11. And 1 and 2 is if you were renting our racks. That's where you would find the phones connected. But with me being a developer, having the layer 2 VPN remotely, this is how I have mine connected. It's also how we do them in the live class. And so show CDP neighbor. We've got our phones connected there. If I show run interface fast 0, 10 and or 11, I see that they have the access VLAN 11 and they're in switch port mode access, and we're going to leave them there just for our tunnel. So actually let's do show IP interface brief pipe to exclude unassigned, and I have a VLAN 11 SVI, so let's do show run interface VLAN 11. I do not have a helper address here. That is one place I could put a helper address. Okay, it's on the same subnet. It's part of the broadcast domain. It would work to put a helper address there. But as we mentioned, we're not using the 3550 switch. We're going to do everything on the branch 2 router. So show IP interface brief pipe to exclude unassigned. I do have a .11 interface here as well. 177.3.11.1. It's a part of this sub interface. So let's do show run interface fast Ethernet 00.11. I also forgot to take out PIM dense mode. In fact, we'll go back and put that on as part of the network infrastructure section here in just a moment, back on our other router and switch devices. So right now, let's go ahead and dive into this interface. And I'm going to change the IP helper address to 177.1.10.10. So that's the publisher, and that's where I'm going to say we want the phones at branch 2 to get their IP addresses from. And I'm going to have IP PIM dense mode. So let's do show run interface fast 0. Fast 0.0/0.11. And notice when I added that IP helper address, it did not take the old one away, which means it will send 2 broadcasts out, one to the router 1 loopback 0 and one to the publisher, and whoever responds first will be the one that we use. Well, I don't want that to be the way it is, so I'm going to take out the helper address that points to the router 1 loopback 0. So now we only have one helper address pointing to the publisher, and we've got PIM dense mode. I'm also going to exit out of the sub interface and turn on IP multicast -routing. Okay, so multicast routing and PIM dense mode on that interface. Do show IP interface brief. I'm going to put PIM dense mode on my serial interface that points back to my corporate headquarter router. How do I know which interface that is? Do show CDP neighbor. Okay, it's this interface that points back to the corporate headquarter router. So IP PIM protocol independent multicast dense mode. Okay, and that's good enough. Remember we said you don't have to have it on the loopback 0. We will take a look at when you might need that when it comes to media resources. I believe that's tomorrow, we said, the end of tomorrow. And that would be only if we're serving traffic from the local router. So let's go ahead and exit out, and we'll write WR for write. That's the quickest way rather than copy run start. You need to have shortcuts in the lab, so that's the quickest way to write our router config. We'll go over to router 2. Branch 1 router 2, and we'll do the same thing. Do show CDP neighbor. Also, actually, do show IP interface brief. So we've got our serial 001:0.1 is our layer, is our frame relay layer 2 interface / layer 3. So we're going to first turn on IP multicast routing. Now we may turn this back off if we're doing alternate multicast music on hold or router spoofed music on hold. But again, we'll come there later. We'll get to that. So we'll join in the interface serial and do IP PIM dense mode. We're just setting up the necessary infrastructure should we need it. And then for VLAN 11, because this is our Ethernet switch module router, our phones are hanging directly off the router, we'll go into the SVI, interface VLAN 11, and IP PIM dense mode. Now remember, we also could do, I didn't mean to end, we could do no IP IGMP snooping. But we're not going to turn it off. We're going to leave it on. And we can do show IP IGMP group membership. And right now we only have the 224.0140, which is actually auto RP, which we don't need to worry about that. For multicast, we can do show IP mroute instead of show IP route. Okay, we're still only seeing the auto RP traffic. We'll see actual music on hold traffic later. We'll write our router config. We'll go back to corporate headquarter and do IP multicast routing. And do show IP interface brief, pipe to exclude unassigned. And we're going to want it out the interface for our servers. Or actually in, as the music's coming in from that interface. Also to our phones, IP PIM dense mode, and then of course out the two serial interfaces. IP PIM dense mode and IP PIM dense mode. And we see that we have PIM neighbor change occurring whenever, and DR, designated router change, whenever we add PIM on devices that speak PIM to each other. Okay? So we'll write that router config. If we switch back over to our switch 1, our 3750 or 3560, we can show IP IGMP. Let's do snooping just to make sure it's on. We see that it's enabled. Version 3 is enabled. It's enabled per VLAN. It's enabled on VLAN 11. Okay. And as far as memberships, we see that we don't have anything yet. Okay, that's no problem. That's fine. The reason we saw a membership on router 2 was because it was actually the router, AutoRP, was joining in the AutoRP group, or at least attempting to. Okay, this is a switch. It's just listening to the nodes, the individual phones. No one's requested group membership yet. Okay, so our multicast is set up. Our DHCP in regards to corporate headquarter and branch 1 site is set up. Let's go ahead and set up our NTP before we go any further, and then we'll set up DHCP for branch 2. So show NTP associations. It's not enabled. Let's just go ahead and set it up. And for this class, and most classes on our racks, we're actually just going to make the router 1 our NTP master. Now the reason I'm not making PSTN router my master, and the lab certainly may, is because our PSTN is actually a 3750, and the newer ISRs have hardware clocks, but the older 3725 routers did not have a hardware clock, also known as a calendar. Cisco calls the hardware clock or BIOS clock a calendar. So they only had software running memory clocks, which they call clock. And so the problem is every time that reboots, you lose the actual time. Okay, so I'm going to say NTP master, and I'm going to say NTP master with a, oh, whoops, I'm on the corporate headquarters switch. By the way, switches don't have hardware clocks either. So do show run pipe to section NTP. Nope. Okay, so I'm going to say NTP master, and I'm going to give it a stratum of, let's say, 2. I'm going to say NTP source address or source interface is going to be my loopback 0 interface. And of course I need to have my time set and my clock zone or clock time zone set as well. So let's say clock time zone. Corporate headquarters is, let's say it's in Seattle, so let's make this PST, so -8 from GMT. And let's go ahead and add a clock summertime. Is going to be called PDT, and it's going to be reoccurring every year. Let's also just show clock, and it says that it's 4:23 in the morning. That's certainly not right. So let's say it is, let's do a clock set, and this is, notice, not from config T, but from exec mode. Clock set 11:23 or 24:00 on April 25th, 2011. Okay, is that the date? Yeah. So the clock has been updated. If I do a show NTP association, I can see the tilde by the IP address, which means that it's configured per the legend, but it's not actually a system peer yet, so we're not synchronized. And that is, we're not even synchronized with ourself. The internal loopback that it chooses is 127. Remember, the entire class A of 127 is set aside for loopback. So anything that begins with a 127 dot is a loopback address. So 127.127.1.1 is the internal IP it chooses. Its reference clock is .local, so its own local clock. It's set up as stratum 1 because we told it to be stratum 2, so it's going to synchronize with itself at stratum 2. But it's sort of, its root clock is 1. And it will eventually sync with itself. It has to. But that hasn't happened yet. So let's go over to router 2. And we'll do NTP server as 177.1.254.1, which is the loopback 0, because that's where we told router 1 to serve from. And actually, before we do this, let's say do show clock. Okay, let's first of all set up our clock time zone as CST -6 and clock summertime as CDT reoccurring. Now let's say do show clock, and it says it's 6:25. We just said the other one was okay. This router 1 is synchronized with itself now. And do show, show clock is 11:25. Central time is 2 hours off, so that would be 1. So let's do a do clock set, do because it's actually an exec command, to 1300, 26 hours 00. We're just trying to get it close so that NTP syncs up quickly on April 25, 2011. And now we'll go ahead and say NTP source loopback 0. NTP server is 177.1.254.1, the loopback 0 IP. And that's good enough. Actually, one other thing we could do that's helpful is NTP update calendar, so that once it does synchronize with NTP, it will update its hardware clock so that the subsequent reboots will be set to the proper time. Okay, we'll write our router configuration and do show NTP associations, where we see it's configured, but it's not set. We see the reference clock. This is who we're supposed to be synchronizing to. The reference clock says who our IP that we're supposed to be syncing to, who they're synced with. Currently, stratum's set to 16. It doesn't go higher than 15. 16 means we have no idea about this NTP peer yet. We're initializing. We haven't gotten anywhere yet. If I keep doing show NTP associations, we'll eventually see this reference clock go to 127.127.1.1, which is who router 1 thinks it's synced with, its own self, its loopback, its internal loopback, non-configurable. Okay, there we go. So now the reference clock has changed to 127.127.1.1, and the stratum is set to 2. But we notice this is still just configured. It's not yet synchronized. Okay, let's go ahead and set up router 3 as well. So let's show clock. Let's do clock set. So let's say 1928 hours, 0 seconds for April 25, 2011. By the way, I can also do clock update calendar from here, so I can go ahead and write it to the hardware clock, whatever I've set manually. Okay, so let's do clock time zone, and let's say CEST, Central European Standard Time. Our branch 2 is going to be most of our examples we've used so far. I'm just going to stay with this for this class. Have been this site at Amsterdam. The branch 1 site is in Austin, Texas, and the branch corporate headquarters site is in Seattle, Washington, both in the U.S. And this is going to be +1. So then also clock summertime. Can't remember if they do summertime. If so, then it would actually be 6 hours off rather than 5, which I set it at. Either way, in the real lab, you would be told certainly what to do. CEDT reoccurring. Okay, NTP source, loopback 0. NTP server, 177.1.254. Actually, I'm not going to put this in just yet. Instead, I'm going to do NTP update calendar, and I'm going to say do, actually exit, debug, NTP events. And now I'm going to put in my NTP server address, 177.1.254.1. And I want to see my NTP packets. Go ahead and write this router configuration. Show NTP association. I see that I'm still in initialization. While I'm waiting for some NTP packets to go back and forth, I'm going to switch back to router 2 and see it's still not synchronized yet. I'm not going to sit here and wait for it to. We'll come back and take a look at it later. Okay, so we'll come back and take a look at NTP packets and actual synchronization a little bit later. Don't sit there and watch NTP try to synchronize water, try to boil. It never will as long as you're watching it. Okay? All right, so let's go ahead and switch over to our CUCM server. We're going to log in with admin and ccie Cisco. And actually, before we do anything, we're going to go ahead and go up to the top right, Unified Serviceability. And we're going to tell this to go there, and we're going to go into our Tools, Service Activation. And we'll choose our pub and our sub. One at a time, of course. And notice some of these services have already been activated for you. That's part of the default server configuration that we have set. Again, remember the real lab may have certain things done for you. There might be service parameters that are already set. There might be enterprise parameters that are already set. It's entirely possible that anything could go. So you really need to be alert. Go check everything. We're going to enable TFTP and CTI Manager. We don't need messaging interface. This is not for Unity or Unity Connection or Unity Express. It's only for legacy SMDI. We don't have any of that. And we're going to enable directory sync. Everything else has been activated for us. Once we're done with that, we're going to go ahead and switch over to the subscriber and make sure that everything is activated that we need to have activated. We do see that DHCP monitor service is one of them that's activated. Okay. That's one of the ones that we need, certainly, to get DHCP able to hand out IPs. It can't hurt to go ahead and do check all services. The only way that that would hurt is in the real lab if you were instructed to only activate relevant services. Okay? So as soon as this finishes activating, I'm going to note that we should always go up to Tools, Control Center Feature services and check to make sure that they're not only activated but that they're actually started and running. Okay? And it does look like our DHCP monitor service is started and so forth. Also, if you ever have devices that are registered, let's say I have a phone that's registered, but when I'm in the administration interface under phones, the registration status or registered to says unknown. If that ever happens, you'll want to come to Tools, Control Center Network Services, choose whichever server, probably you would do both, but choose whichever server you're looking at, or you should see it registered to, and restart the Cisco RIS Data Collector Service. That's the one responsible for gathering the information from the database and reporting it to the web server. Okay, so let's go ahead and go back to administration now. Actually, let's go down to OS administration, operating system administration, and we're going to go here to deal with NTP for the system, the operating system itself. So first of all, remember that I said software upgrades, install upgrade, TFTP file management. This is where we go to find and or add files to TFTP. Just remember, whenever we do that, we need to go back to serviceability and restart the TFTP service. And if we do it on both pub and sub, we need to not only upload the file to each pub and sub, so change the IP address from .10 to .20 and upload it there as well, and then also restart the TFTP services for both. Okay, we're going to go up here to Settings, NTP Servers, and we see that there's 0 records found currently, so we're going to add a new server, give it 177.1.254.1, the loopback 0 of router 1, and we see that upon save, it's going to show us the NTP service is not accessible. No problem. Come right back up here, click on it again to refresh, and now it should say, still says not accessible. Okay, we'll give it a little bit of time. This should change to the NTP service is accessible. And it didn't like me hitting refresh or Control R. There we go. Now it says the NTP service is accessible. This doesn't mean that it's synchronized. It just means we've received a valid NTP reply packet, and we know that we can get to it as an NTP server, but it doesn't mean we're yet synchronized. Okay, so let's go back to our router, branch 2. It's changed from initialization to having a reference clock, but it's not yet synchronized. What about branch 1? Branch 1 changed from not only having the reference clock, but now it's also synchronized. So give branch 2 some time and it will become synchronized as well. The CUCM server, we can SSH into that. You're able to SSH into it in the lab. You'll probably have to do it from PuTTY from your XP candidate machine. And you can do utils NTP status. And we see that we're actually synchronized. Okay, this synchronizes very quickly. We also have a backup, which is our own local loopback. But the stratum is higher, 10, whereas this stratum is set to 2. Okay? And if we were to go over to our subscriber, utils NTP status, we would see that we're synchronized with our publisher. Okay? So it is stratum, or we see it as stratum 11 because it actually sees itself as 10, so it's advertising 1 less than what it sees itself as. Okay? So now we need to go back to our CUCMA, or Cisco Unified Communications Manager Administration user interface, CUCMA, also referred to as CUMA. And we're going to just go ahead and go to our DHCP server. we can click Find and see that we have none. So we'll add a server. We'll say the server is the pub. And we don't need to fill out everything in here. The only thing we want to fill out here at the server level is stuff that does not change regardless of which scope or subnet we're handing out for, such as a DNS server maybe, 177.1.100.110, a TFTP server, 177.1.10.10, primary and secondary. So we see this is option 150. TFTP server name would be option 66. Domain name if we had it. Renewal time, ARP cache time, other things that we don't have to put in there because they have their default. 0 isn't really their actual seconds, it's the default, which if we do help for this page, it will tell us what the actual value is. Okay, and now that we have our server set up, we can go to DHCP subnet off of the system drop-down menu. So now we will create our DHCP subnet. Let's add a new one, and we'll choose the server that we just created. The subnet IP address, this is for the actual subnet, not the beginning IP, okay, but the actual subnet itself, so 177.3.11.0. The first address, we'll just copy that, will be .15. Now, of course, CUCM is going to hand, this being DHCP daemon in Linux, CUCM is going to hand out the IP addresses in reverse. So whatever we put here, which will be .20, it should begin handing out IPs with .20. And the primary router, we can't forget that. Beware, there are a number of fields that are required. We can see with the asterisks. The primary router is not one that's required, which is a little strange if you ask me. But it's easy to, let's say you click Save and it tells you you have to have a subnet mask. Okay, no problem. So we create 255.255.255.0. We click Save. It doesn't give us an error, but your phones won't be able to route or return any traffic because they don't know where to send all default traffic. So don't forget the default gateway. Okay, so we've got our subnet, and our phones have been trying to get an IP address this whole time, so we can go over, and I've brought up switch 2. I've also gone ahead and increased the size of the font per some of your feedback, and on my terminal session. And if we do a show CDP neighbor, we see we've got phones on fast 10 and 11, which we know already. So let's do a show CDP neighbor fast 10 details. And we can see that this phone has got IP address 177.3.11.19. And if we do one for 11, fast 011, we see one's got .18. So did this mean that my handing out beginning with 20, that actually isn't the first IP address to hand out? No, what that means is if I do a show IP interface brief, pipe to exclude unassigned, here on switch 2, there's an SVI that already has the IP address of 177.3.11.20. So the DHCP daemon in the Linux box, the CUCM server, actually went out and did a ping first to make sure that there was not going to be any conflict. There was with .20, so it did a ping for 19. There was no conflict, so it handed out .19 as its first IP address and 18 as the second. So we've got our subnet up, our DHCP scope. Our phones have IP addresses. They should have all the rest of the information. We could go check them. We see that we have reachability to them. That's good. And they have all their proper information. The TFTP server, the DNS server from the actual DHCP server portion in CUCM that we set up, the default router, obviously the subnet mask, and they're ready to go.